Hello, folks. I'm a little bit late today. I was going to actually be a little bit early, but I have some good news. So, this might be surprising to you, because usually accounts get this way, way, way earlier. But I just, with this following, got access to monetization, which is kind of cool. So, yeah, I went and I submitted one thing for this. I have no plans whatsoever to monetize all of you. All my stuff is still free. All the educational stuff is still free. No paid courses, no bullshit. But I put something a little something together for businesses so that they can get like an entry level support chat thing. So we'll see if this goes through. But yeah, that took longer than expected to set up. And anyways, for some reason I posted a random, a completely random plot like at the end of my stream. I just posted this random plot, and apparently Twitter really likes plots. Like, I I don't understand how it is that I post like really full detailed technical articles on stuff, and then I post some random plot and this happens. What is going on with the algorithm? But anyways, I'll show you what happened with that plot, and I'll explain what it is, because I may as well. And it is exciting, actually. It is very exciting, but it's going to take a little bit more work, and that's what we're going to be doing today. Okay, so this is the plot, right? So the problem is that I forgot to run this for long enough. Funny enough. So this stopped at 107 billion. But it's kind of interesting, you can see this thing has an exponential shape, and then at the very end, this is learning rate annealing down to nothing. So you're not really expecting much here. This is the exact same run again, except now I think that because the learning rate annealing is different since it's a longer run, it's not doing as well. So, I mean, we're going to see whether this like has the same takeoff just longer or what goes on here. I'm just going to let this keep running for now, and we're going to fix up the experimental setup today so we can do more experiments and do this at proper scale. But the cool thing that this was here, so this was our Puffer 3.0 baseline for Neural MMO, where we get 8.5 score, which is level 8.5 in the game. The maximum is 25, so this is not remotely a solved benchmark. And then this is MinGrew on Puffer 4. Still the Python backend, but this is the fundamentally new architecture. So without even retuning hypers. So, the question is going to be, can we now do better with this new architecture? And this would be a confirmation both that the architecture is good, and then also, it would say something, well, it would also just like push forward state of the art because this is our hardest benchmark, right? Now, the one thing that I kind of wanted to highlight here, which I thought was pretty cool. So you see that in the old 3.0 baseline, it actually takes 5 billion steps before it starts learning. And the only time I have ever seen this start learning instantly is this run here, which is like this really janky off-policy experiment where you kind of screw things up and it's super unstable. So the fact that we got this level of learning on policy with just a different architecture immediately is kind of cool. Now, I don't know what's up, if it's just learning rate or what we have to do differently, but this is pretty cool. Hello, Kyung, welcome. Yeah, this is what the secret plot was. It was MinGrew. I forgot to run it for long enough, right? So I'm rerunning it, and it's going to be different, and it's probably going to take way longer because the learning rate annealing is different. But yeah, we're going to see what happens with this. It's also faster, which is kind of cool to note. Like, even without any optimizations, it's already faster. You know. Well, it's not just I still need to do hyperparam optimization. It could be better. It's also like this was doing well, and then I didn't run the experiment for long enough, right? It was kind of fortunate actually, because otherwise I would have seen this and I would have concluded it isn't any good. But it's actually, it looks like it's just the learning rate tuning here that is a little bit off. So I think this is exciting, and the goal for today is going to be to get 2048 working nicely with this setup. And we're going to run some benchmarks, and Kyung's here, so I'm going to ask him a few questions about that. So yeah, that's the plan for today. And then also the other thing that I mentioned right when I started the stream is I finally got eligibility for monetization on X, which is kind of cool. So I have a couple things planned with that. Well, let's get your PR merged. And then I'm going to merge your stuff into 4.0 as well today, Kyung. Another business income stream? Yeah. I'm offering one subscription service on there, which is only for businesses. Everything is still free for individuals, and everything is still MIT licensed. There's no shenanigans going on. But I'm offering like a cheaper, like entry level priority chat thing for businesses. That'll be live in a few days. It might plateau. No, actually, it doesn't, Honorary. Let me explain why that is not the correct conclusion. Let me explain. So you see, this is 0 learning rate at the bottom. So this, by definition, this has to be flat here. So what typically happens is you get this type of like plateauing in your runs all the time just because of the learning rate annealing when you use cosine decay. So really, it actually was accelerating up until this very end where it like completely drops off. How much does it cost, premium chat? Launching at 200. It's not for individuals. I explicitly do not want anybody in the community like buying it just to get access to a special chat or whatever. It is like intended specifically for businesses and businesses who want a much, much cheaper way to get some level of service than our normal contracts. Okay, let's get Kyung's PR merged. 418. Oh, okay, it's just a little PR. Fuel. Very good. Football, who makes that? Sega? So when Sega really wants it to exist, then it'll exist. Basically. I'm on the wrong tab. My bad, Kyung. Let me focus here. What does it offer? Access to a priority group DM. So the idea is that instead of having our like typical minimum 10,000 a month contract, and really I don't think we're going to be doing this for much longer. It's really not worth my time to be doing like these size contracts. Really, we're focused a lot more on like custom simulation development at this point, which is substantially more expensive. So I think that it's just going to be like a nice entryway for companies to get like some level of additional support, while not just being like filtered through the whole gigantic Discord that moves super fast. And we'll see how it goes. It's experimental, right? If a bunch of companies sign up and like it, then we'll keep it. If like a couple people sign up and they're like, really, it doesn't make sense to have something that's like this. It's kind of like it makes more sense to either do something larger or nothing at all. And we'll get rid of it. We'll see. It's an experiment. But, what is definitely going to happen is that these contracts are going to go up over time. So having some sort of entryway seems like a good idea to me. Have you tried any local benchmarking tools or any profilers? Of course. We do all sorts of local profiling with PufferLib. How do you think we optimize it so much? Yeah, that's a good PR. Whoops. Okay, and now what we're gonna do is let me get my term set up. And I think we're gonna merge this into 4.0 and we're gonna get some experiments going. Do not know the possibilities of RL? Yeah, so this is not our focus for clientele though, man. So our focus right now, we are not trying to convince companies to come do RL. All right? Like, I'm not trying to sell companies on like, hey, this is why you should do RL. This is for companies that know what RL is, kind of want to do it. Maybe they've tried and it's hard. All right, this is for them. Because otherwise, like, I'd have to spend way more of my time on like marketing and like accessibility and stuff. And I just don't want to do that. I'm a scientist, I'm an engineer. So I want to spend as much of my time as possible working on advancing science and tech. And then for the people who want assistance with that, their services. So far, it's been remarkably effective. Okay, so okay, we have 4.0, and let us open a quick PR. We already did the full 2048 in, right? Yeah, I'm pretty sure we did. So this is going to be from 3.0 into 4.0. Let me make sure I do this right. Not automatically. Is Kyung an advisor? Kyung is a contributor. And Kyung has been a contributor for a long time. He's worked with me back since Neural MMO days during my PhD. Hiring into the Puffer team. So we currently do not hire full-time, Honorary. We hire people as contractors for specific projects. So when we have a company that wants a project with us, then I pull people from people who I've worked with, either throughout my PhD or from open source in PufferLib. People who've demonstrated that they can handle large projects, and I hire them on for that. Benchmarking in Rust compilation kind of sucks. That's what you get for using Rust. Our compilations are instant in C. That's just language diff, my friend. It is one of the largest marks against Rust, I would say. I love that in C I can just compile a dev build and have runtime checks for all the memory bugs and things. And then I can just remove those flags and have a fast build that doesn't have those checks. And not have to like mess with any of my programming, like the way that I build stuff at all. Yeah, and I think after this, for reference as well, I think after this we're gonna have, I think starting in 4.0, we're gonna have a rule that it's only like bug fixes that get put into major releases, and new content like, you know, new environment stuff is gonna have to get merged into dev branch, and then dev branch will just be instantaneously there, and then we'll work to keep the dev branch more stable. This is small enough that I can probably just do this, right? 3.0, them from base, 1E10. Keep Kyung's version, and I'm actually very curious how you handle timeouts, Kyung. Because, like, it seems to me like this would produce a bunch of jank situations where it runs really long experiments early on for no reason. But, like, presumably not, right? Tech.numems. If it produces NAND, then sweep moves on. But what if it just runs a really long experiment, man? Like, if you have 1E10, because it can only, its prediction of cost is not going to be very good early on, right? Okay, this num mini batches thing is going to be in 4.0. This is a 4.0 change. Then this set change. Oh, cool, there's a button. Huh. You reduce to 1E minus 14. Interesting. Okay. And you have a custom policy. Cool. Welcome, Ratswag. Yeah, so I messed with, I did a little messing around with the policy. We're gonna have to fix a couple things, but that's fine. We'll do that today. Current change. Yeah, this clip coefficient is super sketchy, by the way. Are you renting your own compute? Right next to the pufferfish. You see these? We got these servers, and then we've got these two servers up there. All on the wall behind me. And we got like one unexpected contract. We got one unexpected rush order contract this week as well that I'm going to finish, and then probably that will go towards buying us another bigger server, which will be kind of fun. Right, so this one is, we got rid of the cosine annealing scheduler. I believe. Company contracts main source of income, yep. We mostly build custom sims. And then we get Obviously, we don't just build the sim, we also make RL agents train on the sim. Right? That's the whole idea of Puffer, is we're quite good at that. Tell them how many experiments you run on these. Let's just say that each one of the bigger servers can consume more data than all of ChatGPT pre-training. Quite easily, in fact. Okay, so this is Eta Min. So I think we're going to keep yours on this one, Kyung. And then... the optimizer, though. Oh, I see. Method in. Here. And I think we're going to try to move away from Heavy Ball as well in 4.0. Because Muon is in Torch now. We'll have to do a perf comparison, but I think that's going to be the goal. Because the compilation is really obnoxious. I really don't want any form of compilation by default in the loop. I want you to, like, install PufferLib, and I want it to run instantly. Oh, this is so jank. Look at this, it flipped it on me. I made this PR go from 3.0 to 4.0, and it fucking flipped it on me. It is so obnoxious. How's Mingru? Mingru is doing well enough, I'd say. We got one cool thing, but now I'm working on getting this to... I'm getting the stuff that we need to test it integrated from 3.0 into 4.0. Changes into 4.0 from 4.0 merge. Okay, merge. Good. Cool. Get rid of this 4.0 merge. Thank you, Kyung. Oh, and I also have to do your min learning rate change in Python. Python land. GPU rack. Nope, Henri. We have 4090s and 5090s. If you want to have well, if you want to be very amused, go look up the performance difference and the price difference between 4090s and A100s. For what we do, the 4090s are literally faster than the A100s at a tiny fraction of the price. The X post assumed it was Mingru. You are correct. The pink one was in fact Mingru, but there's some learning rate shenanigans to be dealt with. Okay. This is merged. Oh, I see. Nice. Okay, we have to do something about this, Kyung, because this is like 14 megs worth of weights just for the default call. I think we might just have to make it so that I don't know. And we might have to make it so that like the weights only go on the website repo or something. 3x speed your stream. How much do you typically pay contractors on average? Out of curiosity. Half of it, Jess. 50-50. And you're not expected to do like the entire thing solo. I advise and I occasionally will help with engineering as well. Making it easy via pip. Yeah, I agree, and we definitely have to do that in 4.0. Because the puffer is getting a little bit fatty. I gotta lean him down a little bit. Alright, so oops, not that one. I want to have multi-GPU sweeps going today as well. Does that make sense, Kyung? We do multi-GPU against G2048. We'll run 6 GPUs against it. That's the goal. Ay. Did I break? Yeah. The only thing we gotta figure out is this Muon shenanigans. Maybe we can punt on it, actually. Maybe we can punt on this. Maybe we'll do it after. Oops. Jess is learning. Waiting on Spencer to unbreak self-play. Sounds good. Yeah. I did my Saturday marathon and then just crashed yesterday. And by crashed, I mean I did 60 sets and then crashed, but kind of just end up lifting weights for hours on end on Sunday until I no longer feel like completely stressed out. I end up getting in basically a full week's worth of a training program, so even if I skimp on some of my sets throughout the week, I kind of have it banked. It's so funny though, every time I post this, like a bunch of nerds come out of the woodwork to tell me that it's like a really bad training program when it's not. Like, oh, doing any more than like 10 or 12 sets is suboptimal. Like, yeah, per body part. I see you use both Neptune and Wanbi. How do you use each? Wanbi for model registry. Nope. We just support 2 different backends for Ronaldo. We're kind of waiting to see because Neptune has alluded to deprecating some of their free stuff in, in a month or so. And if they deprecate it so that there is if there is no free version of Neptune and none of our current clients complain, I'm just gonna strip it as a backend and we're gonna go back to Wandby because like that's ridiculous. You know, I'm not gonna have a default support for a paid logging tool on our free state-of-the-art reinforcement learning library, right? Yeah, and the new Wandby update actually looks pretty good. Got back into lifting and I'm happy camper. Leg day was rough though. Yeah, so what I do is I do very, very minimal leg training. The only leg training I really do is I do a couple things on Sunday, and then I do my deadlifts. Speaking of which, I gotta go get my daily one in. And then I run a lot. So my running is my leg training. I was lazy this morning. I only did a 5K. I didn't do my normal 10. Dude, what is wrong with Torch? I have a feeling their dev build is just slow as well. That's super slow. Yay. Oh, let's go take a look at our PR in the meantime to see if they got to it. GitHub. This tab. Oops. Massive calves. Yeah, I don't train my calves at all, and they're not bad. It's just from the running. Nobody reviews. 0 people. 0. Okay. Well, I guess we'll probably have to make a local version then. With the assumption that they're just gonna take forever. It's kind of insane that they're like prioritizing the Python backend to the point that they're not implementing their shit in C++ anymore. Because like they literally just make everything slower without compile mode on. So the point of Torch was to be eager mode, and like they just make everything slow without compile on by doing that. Gotta tag that guy? Which guy? It wasn't ever assigned to anybody. Right? Is this one? Yeah, this never got assigned to anybody. This just got like bullshitted, and then I redid it here. I got sick of fighting their CLA for hours. Okay, so to do today is going to be make experiments run in Python, and then it's going to be have stable local version of Muon that does not require me to compile PyTorch horribly. But I don't even know what it's doing right now. Who was on the team? They replied, but I don't think they replied about merging it, right? They replied to me about like setup and stuff. Welcome, Peru. Let me get a cup of coffee and get a another couple sets in while I do this. Gonna do some light training today. Hey, Will. Welcome. What is Torch even doing? I think we're gonna stop this thing, and we're just gonna get it to work from a local build. I mean, a default build, because it's ridiculous. Like, I can't work with that. Is complaining about Muon? Yeah. So we're gonna have to fight this a little bit, so that the Python builds, but then we'll be able to fix both the Python and the C++, and we'll be able to compare them. Okay, so what is wrong with this? Muon options. Expected template. For Cerberus. The goal this week is to deal with a lot less bullshit than last week. Because last week really was starting to burn me out with, not even the amount of work, but just the amount of bullshit, you know? With the C++ and all this, like, I want to get back to running experiments and writing C, and even writing kernels was less bullshit than dealing with Torch. It's not very good C++, honestly. It's not even that, it's like the C++ is bad, but then on top of that, it's actually pretty, like, big tech over, like, bulky, bloated C++ at the same time. It's like, yeah, of course nobody likes the C++ backend. Pin memory. Oh, Peru, I have one as well on that, right? So we got that to work. Here, let me show you. Did I not show you this, actually? And I still have your PR in mind. Where is it? Did I not have in here? Anyways, I got it to work. You can pin memory. I don't know if I haven't tried it across threads though. So I got it. Yes, you can pin memory, like for the ends and give the pointer to an env. I have not tried it across threads. Yes, it improves transfer times by about double. Multi-threading with pin memory. Good job, man. That's actually very useful. So, okay, let me see. What am I looking at? We've got pin copy. Send step. Okay, so what is this showing me? Just I see one big copy, right? I'd need something for comparison. Is this supposed to be showing me that it's one copy instead of two copies? You spend time in env or block running the LSTM? Okay, cool. Haru, can you answer me one question? Is it possible to buffer memory transfers? So while the forward pass for the network is running, can we be loading more data from other ends onto the GPU? So basically, instead of double buffering just the environments, we do one more step and we also buffer the transfer onto CUDA. Even with non-blocking equals true, we are just blocked. Well, of course you're just blocked here, though, because you actually need that data, right? But I mean, let's say that if instead of 4096 M's, if you have 8192 M's, right? And then you .CUDA the first set 4096 it blocks, and then the network starts running the forward pass. But at the same time, can we have the observations for the other 4096 M's be going to CUDA? I think you should be able to buffer that. Can I safely train with 4.0 branch? It's not stable, Jess. I wouldn't try it yet. This is really for me for dev for now. I can run some experiments sometimes, but I wouldn't like, yeah. How does that work with the eval and train loop? Well, during training, you don't need any device transfer. That's fine. Like, you don't need any of it. And then in evaluation, it's just you double buffer, right? So you have a block of environments that's running, and you have a block of environments that is, like, currently being consumed. I already have this working with PufferLib Python version. It's just that the transfers don't also get buffered to the GPU. They only get buffered from CPU. Heck? If you can point me to a PR, what PR do you want me to point you to, though? What? Like, this has just been a feature for a long time. Segments in each block are just serially waiting on the end and getting the action from the GPU. Yeah, of course they are, right? Because you don't have double buffering implemented. If you just look at the 3.0 vectorization, and this is described in the papers as well that I've written. Right? This is basically, it works similarly to envpool, but with some additional optimizations. Yeah, so like when you receive, it's not just like receive from all ends. It like goes through the workers to see which of them are done. It actually will go through the workers to see which ones are done and form a batch. but the other ones are still stepping in the background. But the thing is that they're not writing to shared memory. And then if they were writing to shared memory, like once a batch is done, we could also have this thing just move it to the GPU. We'd have to figure out how to do it a little bit, but I think it would be awesome. And with threads, I think it makes sense as well. A little harder to do with multiprocessing. Eval loop outside, taking this batch separate. Wait, does the eval loop outside taking this batch? So the way that it works is, it's like, let's say you do reset on all your ends, right? You call reset. Now you have 8192 observations that are ready. You take the first 4096, you run them through the network. Okay? And now you have a batch of actions. So you call step on the environment with those actions, but you don't wait for the observations to come back. You already go and start consuming the next 4096 observations, right? And by the time you've produced actions for those, you should have observations ready in the previous one. But right now, those observations are only ready for you on the CPU. They're ready in a big, like, array, right? So if instead, once they're ready, they were also transferred to GPU, then by the time that you have a batch of actions, you should already have a batch of observations on the GPU that are ready. You advise undergraduates to drink less. Was that from experience? Yes. I am proud of this. This is a true statement. I got through undergrad, grad school too, for that matter, but I got through undergrad without touching anything but alcohol in California. So I figure that's not bad. I did drink too much. Could you just batch per env instance? No, you have to batch a lot more than that, man. CUDA streams, it should be possible. Why do you need CUDA streams? It should just be a dot, like, to device with non-blocking. Python overhead is very small. Well, there's zero Python overhead in C++, right? We should be able to get, what is it? It's 32 gigs a second, PCIe, isn't it? Or is it 64? Help synchronize. We might need to do that manually. I think the non-blocking does that under the hood for you. I'm not positive. Oh, did I not? I probably just didn't export it like a dummy, right? The class. Yeah. $32 gigs a second. That's the transfer, right? That's host device on PCIe. What's the amount of data we should be able to transfer per second? Isn't it 32 gigs? Double buffer in evaluate. Maxed out on C. Well, the thing that matters, Peru, is that the thing that matters is threading versus multiprocessing. Because it's really annoying to do with the Python multiprocess backend. Oh, this probably needs to be compiled with the C++, right? Yeah, I'm dumb. Here, we'll fix that. I'm not sure my initial intuition using libtorch. So Peru, it's really obnoxious to figure out how to do shared memory when you have a multiprocessing backend in Python, because having shared arrays for multiprocessing and pinning them is, yeah, there's a tough bit with that. I remember spending quite a while trying to figure it out. Okay. That's independent of C++. Well, it's not. It's a language restriction in Python that you can't do native multi-threading, right? Like, you couldn't implement it with threads in Python and have it be fast. At least before Python 3.14. Okay, cool. Walk through the core of PufferLib. Once we get 4.0, maybe, Jess. No, this is separate, Peru. This is totally separate. The point of doing the entire eval and train in C++ is then I know for sure there is no Python overhead, and I don't need to use torch compile, which adds like annoying startup time. And when you try to start optimizing torch compile, it's actually harder than just writing C++, believe it or not. And also, like, we're going to need custom kernels, so we're going to have to write some torch binds anyways. And now we can even test those from C++ and test them from Python. Like, I guess it is technically possible. Star puffer. Do star the puffer. Oh yeah, for anybody who's new around here, feed the puffer a star. He's hungry. It helps out a lot. Graph go up. $5K this year. I'd hope so. I'd hope so. That'd be nice. Options does not name a type. Really? Wait. Did I do something screwy here? I do not enjoy C++. Yeah, this is a full def. Oh, you know, hang on. I bet it's this. Somebody linked me a Minecraft environment that was like 2,000 steps per second. Like, hey, look, it's super fast now. SKSSTS. I found a cool game this weekend as well. Actually, I'll show this on stream because this is so freaking cool. Like for thinking about research and stuff. Because somebody basically made neural MMO, but they did it with scripted bots. And they'd like made an actual full game, not a research environment. So this is like a full-on MMO, but like, and you can group with players and you can do whatever, but it's all scripted agents. So it's like as close to a multiplayer MMO as you can possibly have, but it's a single-player game. So I don't know. This is gonna have some really cool ideas in it as well for Neural MMO 4. I'm sure. And I can also play it and have it be fun without it being straight heroin, which is kind of nice. Yeah, it's local. And yeah, I think they have mod support. But I mean, it's the same problem you're going to have with every game, right? Which is not being designed to be run in an RL setting like this, high perf. You can always just like get around it by spinning up 100,000 cores, but I don't know, maybe we'll do that eventually. That's like quite a bit. 100,000 cores. Yeah, that's still a lot of money. It's still a lot of money. If you can solve that problem, you let me know, but I don't know how you run arbitrary slow code. Okay. See clones of Minecraft. Yeah, so basically, open offer, right? If anybody has one that is actually fast, which is probably going to be trainable from state, that would be an amazing addition to PufferLib. If it's like at all a reasonable version as well that has like, you know, some usable amount of stuff in it and it's actually fast and you can get agents, like if you, let's say that you just got the terrain gen, uh, reasonable and like basic caves and stuff, and you got an agent that like goes and makes a pickaxe and goes and get diamonds or gets iron or whatever, like that would immediately qualify you for contracting work with Puffer as well, like that size of a project. So it's pretty much just like the quals are pretty much just having written a clean, like a version with clean, simple code and like working RL for a medium-sized custom sim project, because that's what the client jobs look like. I mean, you do also have to be like not completely schizo. You have to be able to work professionally, but main thing is being able to deliver something like that autonomously pretty quick. Is there a template for Jack's Place environment? Gymnax, Puffer, and Crafter. Yeah, so I have not maintained that particularly well. So let me know if there's any bugs with it. But yeah, you can use that, right? The Gymnax Puffer Env. I mean, you can really use whatever you want, frankly. Because our API is just a standard VecEnv interface. So if you just match our VecEnv interface, you're good to go. Minecraft server that runs on ESP32. That's just the server, though. I mean, we don't need... There's really not much more you need than the server, though. You basically just need obs sizes. I mean, it can't be written as a server, though, that you have to connect to with a client, right? It has to be, like, one block of code. I think you could probably do... You could probably do, like, a decent Minecrafty end in no more than a few thousand lines of code. For sure. It would be a bigger project than, like... It'd probably be a project that's, like, bigger than Terraform or whatever, but, like, I wouldn't think it would be any bigger than Neural MMO or MOBA. The rendering for the demo might be a pain in the ass, because, you kind of do have to do a little bit of custom rendering. You can't just render everything as cubes and have it work. But that's not anything to do with the agent. Oh, cool. This runs. So let's figure out the scheduling. Ah, yeah, there you go. Thanks, Kyung. Use that. Because either my math is wrong or you figured out O of n scaling for multi-agent. What do you mean O of n scaling for multi-agent? Multi-agent is O of n. O of the number of agents. Watched one of your YouTube vids yesterday and had to follow Puffer super sweet. Welcome. Come build some cool environments with us. Most of the things on Puffer AI are community made. Like most of these environments are by contributors. You kind of just can jam some low-level game dev and advance RL in the process. Thinking of moving my Jax M's to Puffer. I have them set up as use VMAP for the parallel M's. Will I lose that speed as it uses multi-thread? No. What you would do with that is you would not use one thread per environment. You'd run so you run env instances serially, but you do like, here, if we're going to do like an 8-core setup with 8,000 environments, each core is going to run 1,000 environments on a single thread. And it runs them serially, sure, but like, it's still fast. Unless your environment is really compute intensive. I mean, a very easy test of this is like, what's the steps per second you get from your implementation if you just run one environment on one core in C? Because it turns out a lot of the time, it's just way faster than you would think. Particularly if your jacksums have like a bunch of branching or stuff in them. Like CraftX, you'd think, oh, it's massively parallel. It runs on the GPU. But actually, I guarantee you that env is slower than it would be on CPU. Depends how much branching and stuff you have, man. So, like, if you look at CraftX, that thing only runs 100,000 steps per second because it has a ton of branching. It would be, because it's a game, right? It would be millions of steps per second, probably like a million per core, couple million a core, depending how you optimize it, on the CPU, right? But now if you give me an environment that like you can do the napkin math on flops and it's more flops than your CPU can produce, but it has no branching, then that's obviously a GPU environment, right? Now the cool thing is you don't have to do one way or the other. You can just plug your environment in and use Puffer's training algorithm either way, right? Like I did this little experiment in 4.0 where I wrote a CUDA environment. And yeah, we can just train on a CUDA environment because it's a vec-env interface, right? It doesn't really matter what you have as long as you have a vec-env interface. $100 million steps per second. And then what do you want to move them to Puffer for? Is it getting hard to build them in Jax? Like, what do you want, right? For anything that's not trivially pure array ops, it is easier to write C than Jax. I will say that. I want to use your train loop and tools, and then just bind your Jax-env to Puffer, right? Just standard vec interface and try it out. Yeah, just write a simple env binding. It's a few lines of code. Puffer really doesn't do any magic. It have to be in C. You do not have to write your M's in C to use PufferLib. You are free to bind however you like. We have our default binding set up for C, and we take contributions in C because that keeps the project much, much simpler. And frankly, C is just a really good language for SimDev. It prevents people from doing a lot of stupid things that they would just naturally do in higher level languages, even in C++. Um, so yeah, like you can write stuff in other languages if you want. You'll have to just do the same sort of binding as we have set up for C, though. Ultimately all you need is a vec-env interface exposed to the training layer, which is currently Python. There will be a C++ option in Puffer 4. But there's really not any magic. Puffer is not like a gigantic library where you have to guess how on earth you're going to be able to interact with it. Like pretty much any question you ask, there's somewhere between 10 and 100 lines of code somewhere that just do the thing that you're asking about. You can do stuff in Odin if you want. You're going to have to figure out... The only thing you're going to have to figure out that's mildly annoying with other languages... Let me show you. So this is our env binding file in the current public release of PufferLib. So this is the Python C API, and we use this to bind from Python to C. And we also handle, we run the loop over environments in C using this as well. You'd need to have some sort of binding from your env to Python is the only thing. So you can run PyTorch models. I don't know. It kind of depends what your objective is, right? If you're trying to learn RL and just jam some low-level dev, the C is awesome. If you're messing around with Odin, you really want to do Odin, then sure. But I don't really want to take contributions if that's your objective. If you want to build an environment and PR it, I really don't want to take contributions in other languages at the moment, because then I have to just make the build system so much bigger, right? Because then the build system has to support multiple languages. It just bloats the project. When really, simple C just takes you so far, and it's so bloody easy. Right? That's pretty much the only reasoning. If you actually look at some of the env code in C, it's so easy. I mean, of all the languages I could choose, right? If I'd chosen to do PufferLib in Odin, that would probably work, right? I could have chosen Nim. There are a few languages I could have chosen, but I'm not going to choose a niche hobbyist language, right? That isn't widely used. So of all of the major languages I could choose, C is just the best choice. C++, people do too much stupid, overly complicated stuff. Any of the higher level langs are just too slow to use on their own. You need manual memory management. So probably just C is the only option based off of that. And the C is nice. I have very, very few complaints about the C in general for this. I don't know, maybe string processing sucks in C. That's about the only thing I can think of off the top of my head. Okay, this is the last thing that we needed here, was the min learning rate thing, right? Eta min. Minimum learning rate. Okay, so I can just do eta min. Learning rate times min LR ratio. And then what do? Learning rate T Wait, what is this? Ah, I see. And yep, we have to update this. One cycle L. What is that? Heh. This could be a cool thing to test. This would be a very easy thing to ablate, actually. So yeah, Daniel, if you want to try this thing out, this would be like a super easy set of experiments to run. You just grab Puffer 3 and then like run some environments and see if you can get any speed ups with sweeps. I would actually believe that this could make a big difference. Because this is basically cosine. This is cosine right here, right? So this is cosine decay with warm up. Can this represent cosine, I wonder? Have you only tried cosine? No. We had linear, and then we tried a couple other things. And it seemed to me that of the things that I tried, it made a very big difference to have learning rate decay versus not to have it. But the specific method didn't matter a lot. I think I also tried like the step, like the constant and then decrease at the end or whatever. But I didn't try anything that like warms up super high and then decreases. I didn't try anything with warm up. Reduce on plateau. You can try it. The thing is, you'd have to define what is the plateau. You'd have to use like environment score or perf or something because your loss function is not going to look like a plateauing thing in RL. Like your loss function is going to look weird. RL. T cur. What's T cur? Maximum. Maximum number of epochs in a cycle. Huh? T cur equals T. Oh, I see. LR ratio is this. So this is fine. So we just do this. Hello, could we ask questions? Of course. Why do you think I stream all the dev? This is the wrong one. This has got to be Python PufferLib. Is that the Dunning-Kruger graph? That effect is only ever brought up by dumb people who think that they're talking to even dumber people. Welcome, OD. Pretty good. Pretty good training. That is a full solve. So that is a full solve with the new code base. We should be able to do 2048. And we'll have to configure a couple things. Size is 512. Right, so this goes away. This gets commented. Attribute initial state. Right, so now we have to figure out the policy and how we're going to handle this. Yeah, so right here, I kind of just did, ooh, I guess we can kind of just hunt on this a little bit. Can I do LSTM wrapper? Yeah, so this is the default policy. Let me see if I can just get this into, okay, so this is his policy. That's not bad, right? Scale the features. Well, what if I just do it like this? Can I just do, I take the default model here. This. And then I just do self.20 this. Self.g. This has encode observations. Now let's just make sure we don't mess up the all too crucial forward passes. This has forward eval and forward train. Obs.shape. Yeah, let's do it this way. So now we can just do self. So forward is just going to be self dot 48 code observations. Code actions. And then we'll do the exact same thing here. Okay, so now we have hopefully fixed the policy. See if this works. Hey, it runs. Oh, and it runs reasonably fast, actually. Young, you kinda gave me something that takes an hour to run a baseline. So I'm not gonna run this on the local machine for sure. But I think initially what we can do is... Yeah, that's the soda run. Cool. So, let me go get both networks working. We'll get Mingru working on this as well. And then I guess I'll go launch a couple GPUs worth of this so it'll run for an hour. And while that's running, we'll figure out sweeps. Multi-GPU sweeps. This is going to be a very nice test environment, let me say. Very hard to find environments that are like this solid. Mingru. And we're going to have to figure out some better thing to do with the models. On one hand, I'm kind of sick of the LSTM wrapper thing, having to, like, wrap your policy. But I guess we'll have to figure out if there's, it's the least of the evils. Good observations. Cool. This one ran 2 milliseconds. To wrap up on pin memory torch thing, looks like with your C++ native multi-threading, it should automatically batch. Take advantage, correct? Anything else I should look into? The only thing we don't have, I think, is... Well... We're gonna have to do the double buffering, or like the end buffering thing, I think, in C. And then the only thing I'm not sure with that is, once you have an entire batch of data, I think it needs to get transferred to the GPU asynchronously, which, yeah, that's going to add a little bit of complexity. I'm going to have to think about it. I'm definitely integrating your threading stuff, though, like, guaranteed, because I already wrote, over the weekend, I wrote a vector interface in C, and it works, but it doesn't use threading or anything, right? It's just single process, but it's a vector interface. So your threading is going to go into that, and then that's going to get bound back to Python, so that there's the Python version of it, but then there's also going to be this pure C++ version. I don't know if it's going to be pretty easy. I don't know about that one. I'll do it, but I don't know if it's going to be pretty easy. Zero locks, no worker queues. That's good. Did you copy the busy waiting thing? Okay, so this one is currently this is slower than the original architecture, but this is zero optimizations. This is not unexpected. We'll go run both of these. Okay. Now we should be able to launch this. First time here, what are you working on? This is live stream for PufferLib. So I develop high performance reinforcement learning tools, library, research, all that. And I am currently working on testing out a new architecture versus the original baseline on a new environment that was just merged in. 2048. So actually, it's a good time for people watching. It's the game of 2048. And we're training very, very good agents to play this. And I'm using this as a benchmark for a couple different neural net architectures at the moment. Because the new architecture I'm testing would be awesome if it works for Puffer 4, but it needs some confirmation. They're a list of highly wanted type of env contribution. So the absolute best thing is if you have experience in another area and you see the opportunity to have like a real world application and you can build like a cool prototype environment, that's the best. But other than that, like, if you're just generally looking for something fun to do, pretty much whatever low-level game dev is chill, because it's kind of unintuitive what environments end up being useful or not. Like 2048 ended up being a really, really good environment for research. Generally, having environments that are like challenging or interesting in some way than that the current environments are not is good, but it's kind of difficult to predict that ahead of time. Gotta update the website? Yeah, of course. And they get the new agent onto the website as well for you. Is that thing gonna load? A 16 meg policy? It'll probably load. It probably just takes 10 seconds. It's annoying, but alright. We gotta figure out something for that. Yeah, we'll have to figure something out for that. Oh. Good environments in context of finance. Yes. So we do, oh, macroscopic. Lower moving. Pretty much everything so far has been trading related. We do a couple things for that professionally. Not like our main area of specialty or anything, but it's an area where you can build sims and build like and run agents, so we do. There's some 3DMs, Thomas. And actually Raylib supports 3D rendering. So we've got like we've got this drone environment, so this is 3D. There's actually a drone swarm environment for this as well. There's this 3D puzzle game. Also, is 3D in here. This is pseudo 3D. We got this one. This is like 3D. Oops. This is terraforming environment. Top down, but 3D. A few others. How is this different from environments frameworks around gym and stable baselines? Because everything here is between 100 and 1,000 times faster than stable baselines. We also have like fundamentally better algorithms in several areas. That's not an exaggeration either. We train millions of steps per second per GPU. There's absolutely a risk of overfitting. It depends how good your sim is, right? So if you're overfitting to your sim, but you have a bad sim, that's bad. If you're overfitting to your sim and your sim is the same as the real thing, then it's not bad. Sounds great. Yeah, take a look. It's all open source. I work on this full time. What happened with this? Test binding SO cannot open. Ah, right. Python. PufferLib. There is one end that's very, very simple that I've been meaning to release because we got permission. The other ones are not. The only thing that we really... I mean, the main thing that we sell, right, as a company, the main way that we buy servers and maintain the project and everything, is that we offer custom simulation development services, right? So I'm not going to give you more than vague details of like the types of projects we worked on for those, and those are typically not open source. Oh man, that Env Kyung. That frickin' paper. That was like such a weird paper. That was basically Salesforce arguing that they should pay more taxes. I have no idea where that came from. Or how that got okayed. Oh, Socher, right. Yeah, it makes sense. Okay. Socher's kind of nutty. Welcome, Lance. Didn't realize. Yep, of course. Yeah. I mean, that's the main thing, right? So, like, I kind of like the way that this project is in the sense that it's a combination of like everything's open source, everything is out in the open. I don't have to charge users anything. I have no impetus or need to try to monetize users at all. And at the same time, you know, for companies that are using RL in really valuable projects, there are much more expensive services available around that. It's a nice little split. And it lets me spend most of my time just on research and development, which is awesome. Reimplementation of carbs. Is there any population selection and resume? Uh, so hang on, let me answer that. So first of all, I don't know what the heck Agile is doing. Do you? Like, I saw their thing. There's this. Are they? Is this one? They have their own dashboard thingy. This Agile and home. They're still alive. Yeah, they're alive. Oh, they're doing LM stuff now, though. yeah, of course. Um, I saw their hyperpram stuff. Like, somebody would have to go try it versus our own stuff. Um, but what we have, it's kind of like a genetic alg, but it's over the Pareto optimal set of points. So you're doing like a search, an expansion that is guided by a Gaussian process, and it is around the set of Pareto optimal points with respect to cost and score. Go and get. Yeah. If they are using just gym ems, it's actually impossible that this is fast though. The next faster hyperpram optimization. Yeah, but Optuna doesn't even have good algorithms in it, right? Oh, is this multiple? Okay, so this is then they're doing something very different, right? So this is yeah, I see. So they're doing something that's kind of like population based training. Yeah, they'd be doing something like population based training for this. Right? You know. So we don't have carbs though, man. So our new algorithm is called protein, and it's an advancement over carbs based on our own research. Protein doing though? Do you have any population checkpointing? No. So there's the advancements in protein are not on top of the population. They're mostly changes to the way that we incorporate Gaussian processes to guide selection. If you check on X, I have a blog post on protein. So this is Mingru. I believe this is Mingru, and this is yes, this one should be Mingru. This one should be LSTM, right? Yeah. So yeah, we'll see how these progress over time. Population, improve it in your opinion. Are they doing multiple runs though at the same time for that? Because typically the population-based methods, they plot it in steps or whatever, but like the cheat is that they're using a ton of GPUs for it, right? They're like, oh, it's only one run because they're doing all their runs in parallel. I remember that was like the original thing, that it's like, yeah, it's better if you treat compute as free. All right, let me use the restroom real quick. I'm gonna get a quick couple sets in. I should do my daily deadlift. I've been skipping that too many days. So I'll do that, and then we'll see if we can fix multi-GPU sweeps, because I'm gonna want to run a full sweep on this thing to see. I mean, if this is just better out of the box, then yay, that saves us a lot of time. But we need multi-GPU sweeps anyways. I'll leave the charts up. Be right back. Okay. Oops. So ignore the fact that the pink one is faster, because the yellow one's going to be faster once it's optimized. Because right now you're comparing Torch's super optimized kernel to like a completely naive implementation in terms of wall clock. Cool. We'll leave this over here for when I need to mess with it. And We'll probably know in like 15-20 minutes. In the meantime, figure out some sweep stuff, which I think is going to be easiest just on the other tiny box, right? Got 2 of these multi-GPU machines. Want to just double check, because I do have one rush order that I have to work on more tonight. Make sure that they're happy. Cool. Good thing I checked. One meeting to set up. Kyung, is it supposed to do this wavy thing on the baseline? There are like some curriculum shenanigans going on. No, looks weird. Well, that is supposed to be the baseline. Hmm. 0.1. Interesting. It's that 1 bill as well. Yeah, so it's supposed to be way better than this. Goes up to 7 bill. Okay, so what could I have done wrong? Oh, I suppose I should run it with heavy ball muon, right? For comparison. This is with Torch's muon. So I guess it's possible it's possible their muon is just bad. All right, let me go fix that for you real quick, and then we'll continue. Let's see if it's for each muon. Like so. Well, that's actually a crucial detail, right? Because we are gonna have to not have heavy ball in our C++ either way. Okay. This is the LSTM. For now, Kyung. I fused it. Yeah. That's not finalized, though. I still have a bunch of work to do. The UX. Okay. Heavy ball is slightly slower. Funny enough. Yeah, we shall see. Whether these do anything. Does it need to be above 1.7, Kyung? Are you using, like, new features? Alright, let's just... install mesh U heavy ball. Why is it installing its own torch? I hate... Fuck, whatever. We'll see. Hopefully this doesn't break shit. Hey, Tim. We are currently trying to get some real experiments on Mingru. This will also serve as a check on Muon. I mean, Muon versus Heavy Ball. Nope, just Python Mingru to start. It's real slow. It'll be faster though, don't worry. The puffer will be fast. World's fastest fish. Alright, so I will let these run. And let's figure out Tiny Box. Mamba. We can still try Mamba, Tim. I think Mamba's... Well, to be fair, we should still try it. Okay. This pretty much matches before. So we'll see if it's like lower start. Do one phone. Yeah, that's rough. Yeah, so we will just see if this is like slow start and then aggressive takeoff type thing. I wouldn't be surprised. That would be interesting though, because that would also imply that we should retest Neural MMO with the other Muon, right? Hmm. Doing Muon now. Muon is good. Tetris is 1 bill plus 3 bill. Well, we'll try this first, because I want to see what happens, right? Is this supposed to be... And is Puffer any good at very stochastic environments? To the extent that you would expect RL to be, yeah. There's nothing in Puffer that makes it particularly good or bad at stochastic specifically. There's plenty in Puffer that makes it good overall. Honestly, stochasticity is not even really something that we think about as like a dedicated challenge. Okay, so actually your curve is maybe 0.006 at 100 mil. It's like, yeah, it is a very slow takeoff. So maybe it is right, you know? Maybe it's just this is a slower takeoff. Oh, but this is 600 mil. Yeah, this is supposed to be way better. What happened? Why is it so much screwier? Did I do cosine annealing wrong? Oh, wait, did I do 3 layers? I might have done 3 layers. Let me see. Hmm. No. Well, your GRU baseline is wrong. The LSTM one shouldn't be, though. And that's how it goes, Tim. Uh, is there anything else I could have messed up in here, Kyung? It's 16 kms, 512 hidden. Your params. Can't think of anything else. The policy again. Okay, so this is your G2048. I didn't change this at all. Encode observations, decode actions. And then all I did, let's see, so this gets hidden size, right? So I pass hidden size to this, and then I just call compute or was it encode observations and decode actions. Layers is 1. Well, it's not debris because this is a tuned run where we know that in Kyung's run of this, it does way better. So there's some discrepancy that's not that. Okay, this is the min GRU one. I know for sure this one is wrong. Because this one was supposed to be this. Be 3 mil per amps. Not 10 mil per amps. Some layers is 4. But I had your LSTM correct, so I don't know how it's still messed up. Wait, that's closer. Loss curves. And there shouldn't have been any changes to that. It's possible that I have changes to the implementation in this version. Doesn't look like it though. Yeah, this is our normal implementation. This is how I implemented the minimum learning rate, or the cosine annealing. Which would seem fine to me. Oh, you know what it is? It's not mini batches. I got it. It's gotta be this. The only thing that changed from version to version. Yeah, it's definitely this. Here, let me fix this. So this is gonna be 4m's. What is this? Times 40, 90, x times, and then your batch size is gonna just be BPT horizon to 64. Holy batch size. Okay, so num mini batches needs to be 32. 32, like this. Okay, so this is unbelievably slow. Very cool. Let's do it like this. See how fast this runs. Guaranteed I messed it up on Neural MMO as well. Okay, cool. So we'll be able to see the results from this pretty soon. .7 mil params. Set num mini batches. Yeah, I did I total batch over mini batch size. Yeah, so this is because in Puffer 4, you no longer set epochs, you set mini batches by default. And I should absolutely have an auto option for this as well, because like very often you want it to be one you very often want one update, one epoch worth. But this is why it's a dev version. Not released yet. Working on it. Alright, we'll see what these guys do in a second. And then we will continue on parallel stuff. What did they do the algorithm that I just post a random graph? Rockman's also like one of the people who I respect more than anybody else in the field. He's pretty awesome. That seems a lot more mini batches than normal. Yeah, because the batch is gigantic, man. Kung's using batch size 1 million, so. I'm not here to question, I'm only here to replicate today. Is this still not fixing it? Really? Yep, the params matched perfectly this time. Why can we not match Young's run? Yeah, this is 200 mil. Supposed to be better than this by now. Yeah, 200 mil is supposed to be 0.02. It's way below that. Alright, Kyung, why is this thing different? Why is your run weird like this? Is it supposed to be 3.7 million parameters? Is that correct? Okay. So I have your network architecture. Breakout work? Oh, well, that is interesting. Oh, now it optimizes. Let's see if it optimizes way worse than before, though, or something. Yeah, this is like way worse than before with new heavy ball versus with torch. Interesting. What's not getting applied? I bet it's like the learning rate not getting annealed or something. I don't see anything wrong with this, though. This is cosine annealing, right? This is the formula for cosine annealing. I could check this. I could go chuck the scheduler back on it, I suppose. But this is the formula for it now. Is this supposed to be on heavy ball momentum? This is supposed to be on. Let's try this. There we go. Immediate difference right there. Alright, we just broke the optimizer is all. So kind of crazy then that we managed to get a run of neural MMO to do something. What? Is this actually true? Or is this bait? Whoa! That's awesome. That is so awesome. Dude. That's so cool. And good on Riot as well. Really, really good on Riot. For not just, like, killing it in corporate hell. We purchased it. That's so cool. Let's see what happens with this thing, man. Okay, now it optimizes. Lovely. The min grew is going to be 4 layers. 4-layer min grew. Boom. And this will be a stable learning experiment. Mm. 48 LSTM. Okay, we'll give this a few minutes, and we will figure out whether we're back on track or not. Get a quick set or two in. Ah, there we are. That's a proper learning curve. There we are. It's a proper learning curve. Ooh. Cool. So, let's merge this before we forget, and then we will figure out why multi-GPU weird. So Kyung, your environment is now, or your Well, your modified environment, at the very least, is now getting used in proper baselines. Oh yeah. There we are. We shall see how this goes. It'll be quite interesting. And we actually can go fix neural MMO as well at the same time, right? Oh, of course I didn't set num mini batches. Of course. Alright, so this is 8K. Num player is 1024, so this is 8192 times 64. 8192 times 64 divided by 32,768 is 16 mini batches. Would you look at that? I did it wrong. 16 mini batches? Oh, actually, no, that was right. That's the default. Cool. It's just the optimizer then. The optimizer being jank. I'm gonna relaunch this one. Oh. Also, let's just... layers. Expansion factor. Yeah, this is all correct. Oh, but this is literally, not even like a neural MMO mini-brew, is it? That's crazy we did that well. Holy. Neural MMO, lot of steps. Lot of steps. Okay. Maybe we just wait. Yeah, we're gonna just wait on this one because we're gonna need to do the multi-GPU anyways. Just wait. Okay, look at this. So we have this one here, and we'll see how these two progress. This is a lot better, right? Sweep to Tetris. Yeah, and we're about to see whether we can get all this stuff on Neural MMO. Neural MMO and 2048 will be the two hard benchmark M's. Yeah, look at this. This advertising 2FA subscription culture and Microsoft. Yeah. Where's the multi-GPU? It's on the docks, right? Well, it's gonna take a long time with this version, obviously. Normally, it's like a 3-day run. We have extra boxes. We're gonna do 2048 at the same time, man. How did you run sweep on Neural MMO? Very slowly. And honestly, it needs to be reswept. Oh yeah, so this was this weird thing. I don't know why this is doing this. Gotta be like some common torch bug, right? Okay. Interesting. Data parallel, no attribute. Just okay, cool. So we have the command at least. Parallel, no attribute. The hell? Gotta hate the distributed shit. Come on. Really, really, really obnoxious heavy ball. But we don't want to use Torch Muon, right? Because it wasn't working nicely. Well, why does it do this shit, man? True. Oh, this is totally fine. Let me see if it works with the original. Yeah, you see, Kyung? The pain in the ass. And you have to wait, because I'm going to have to go look at the code and see what's different with these two implementations. And the source is somehow even worse than Torch's source. It's like functional hell. Okay. 1 million. That seems really bad, doesn't it? Oh. Why are we so slow? Because we're stuck in the environment loop, okay. 4. Can go to 2. Yeah, well, that's what happens, Jess. Every damn time. It's like, it's just there's hell to pay and there's no one else to pay it. Okay, this seems to run at the very least. And if I run it in distributed, not bad at all. 4 mil. Correct. Yeah, I got 2 of them, Matt. They're right up there behind me. You can see them. Okay, so this works. Now the question is, what is different? Can we go figure out what the heck Heavy Ball is doing? Green, man, I'm not dealing with AMD shit. compile step. Maybe we can just make this thing and not try to compile. Does this take star quargs? Can we just do... Still breaks. Thing. Well, now we have to go figure out what's wrong with this. It's annoying. I want this thing gone, man. It's like... Thing bothers me. Can it be internalized to Puffer? What do you mean? This whole library is like insane functional shenanigans. Well, it's not. It's weird. It's like simultaneously crazy functional and crazy object oriented. Just muon? Well, yeah, but there's the torch muon, right? And like the torch muon doesn't match this somehow. But like the thing is, my muon is not the same as heavy ball muon. It's the same as PyTorch's muon, which apparently wasn't working the same. Go take a look at our run, by the way. Oh, okay, look at this. These two are on par at the moment. Well, yes, provided we make Min grew fast, absolutely. We should be able to do. Yeah, I'm sorry, Lucas. This code's just insane, my guy. Like, absolutely insane. This is like crazy functional and crazy object oriented at the same time. Gives me a headache. Anyone see my Muon? Monday. Nope. Underscore Muon. Well, I ported this already the other day, man. This is what I ported to C++. Ah. Weight decay. That probably not good. Did I catch this, though? Maybe, did I catch this or not? Oh, this will do it. So actually what we're going to do next is we're going to try to match the learning curves on 2048 so that we can get this run going today with Torch's Muon. That would be ideal. Programming philosophy. Procedural, man. It's just procedural. Just write the code top to bottom in the simplest way possible. Done. That's it. Not stable. Nice and stable. We're gonna try a lot of stuff, Kyung. Hold on. Okay, so it solves either way. We probably want this one. Might get rid of the two-phase system. What two-phase? See how we're doing here. Oh yeah. Is this expected? What we want, Kyung. You can try. Yeah, you can try. 0.68 perf. 0.55 perf. 3.4 billion. This is on par. We have spare GPUs on this machine. So I'm going to try some additional things without killing these runs. That I'm going to do. The other tiny ducks go. Uh-huh. I will check in 1 second. I'm not killing the runs, Kyung. I'm just launching more runs on the other cards. If this matches, then we'll be able to use Torches, move on. Of course, it's super friggin' slow. $20. Grade school to learn AI. You better learn well. The market for people who don't really know what they're doing is a bubble. The market for people who do know what they're doing is not a bubble. Reached 32K, so nobody has reached 64K yet, Kyung. And we've got reaching of 32K here. This is awesome. What's your streaming app? I don't know if you need a pro account, man. But I'm streaming through Restream to X, YouTube, and Twitch. Okay, so it's gonna be at least several minutes before we have any sort of indication on this, but this is still going up, a little wavy, it's still going up. Fuel. 3. I want to have this thing done by 4. Not using OBS? Yeah, I'm using OBS, and then it goes, OBS is synced to Restream, and Restream multicasts it to Twitch, YouTube, and X. Like, infinite tunnel incoming. You have Neural MMO 3 Mingru going. We will in a bit. I want to make sure that I want to see if we can get this to match, and then we're going to do a 6 GPU Neural MMO Mingru. Which I think we can get about 4 or 5 billion steps an hour on that. It'll be slow, but not unbearably slow. I'm actually, in the meantime, let's see if multi-GPU sweeps works in the meantime. Let's see, Python PufferLib multi-sweep. Assert is instance of param dict. Never had a multi-GPU? Each run use only one GPU. Yeah, each run only uses one GPU. There's not really any reason to try to use multiple GPUs for networks this small. Like, there really isn't, man. How the hell is this thing at 6.1 thousand steps per second? Yeah, Kyung, this is crazy. Not having a max cost on this thing is nuts. How did you get this to work? Like, it just launches a ridiculous job with params that's gonna make it take forever for no reason. It seems bad to not have a max cost to me. Yeah, it has a max suggestion cost, sure. But, like, okay, first of all, it's not set for Pong to be lower. And second of all, the max suggestion cost is just based on an estimate, right? So that's a pruned cost. It doesn't actually prevent it from running that long, right? Or do you have it set that way? Yes, it's not used in here. So what I had is I had it like this, where it just cuts runs off after a certain amount of time. How do you have it so that Pong doesn't, like, run forever? Because, like, it immediately set up some stupidly long run just by sampling, like, a tiny number of M's when I ran it. Okay, this is like something. Not sweep? What do you mean not sweep? Well, sweep runs train every time, right? Oh, you just don't sweep very small number of M's? Hmm. Get me in Discord. Bye. Oh, this is the old PR. Okay, I await your message. Max cost looks like it belongs under train arg. That is valid. Yeah, I could definitely put it under train args, and then it would be shared across sweeps. It's not at the moment, but I could very easily do that, and it would be better, you're right. Pong was slow. It probably sampled like 5 M's or something, man, look. I have it so that Pong can sample all the way down to a minimum number of M's. So I don't think relying on the shitty Gaussian process to make sure you don't waste a ton of compute is a good idea. I mean, like, if you have asynchronous halving or something, right? If you have some sort of detection mechanism, then I agree that you don't need this. Roger, I don't beta test all the Gen AI models. I think compared to most people you see doing dev, I generally use them very little. The main thing that I use at the moment, I use Super Maven, which is getting killed in a few weeks, and then I use Cerebrus, which serves like not amazing models, but they're very fast. And that's it. So like, what's your recommendation here, Kyung? Because I can see two things, right? I think that it's like we either just don't sweep a tiny number of M's, which is not great. Or we can replace the max suggestion cost, which is a sweep arg, with a max train cost, like a max train time, which is a train arg. So it's a hard threshold. Only samples POW 2. And like hidden. It is POW 2. Look. It is sampling powers of 2 here. But the point is that this could be a valid run. Right? Because like in 4.0, we want to also be able to do sample efficiency experiments, right? Sounds tough for sweep. Okay. I guess the easiest thing for now. I mean, the thing that's actually gonna work though is just adding max cost to train, right? Like this is the thing that's actually gonna work. Keep both. Once GP gets enough data, yeah. Okay. If this does cut off. There we go. Okay, this runs now at least. Well, it's gonna be different per env kyung. So I'd put it so that if it's not specified, there is no max cost. You know? Protein. This one we get rid of, right? Yeah, this one we get rid of because it's a max suggestion cost. Over here. Right? Now we can do this again. See. See if this is stable. Ooh. This is not good. Go on. Well, now I actually have to go frickin' figure out the differences, don't I? Sucks. What the fuck is this code? What the hell? Wait, EMA. Oh, okay, it's Nesterov momentum, not Nesterov EMA. So functions equals I see. So they're different. Okay. That's annoying. So that then means that we need the heavy ball version until we can test these equal. At least one difference. So I have Nesterov equals enables Nesterov momentum. Momentum factor 0.95. How the heck? What? There's no momentum param though. Is it beta? Beta 2. It must be beta, right? This is EMA. Ah. Great. So this one looks good. Mingru so far matches, which is great, actually. And then it's just the question of the optimizer. No, it hasn't reached 65k. Well, maybe this one has, let's see. Nope, nothing 65k yet. Although, still though. I guess we just figure out why the hell Heavy Ball's broken for now. Like, what else can I do? Buffer size? Is there no buffer size in this, Kyung? No buffer? I guess I just did a bad merge. Alright, we'll do this for now. We can see if this works with Heavy Ball, I suppose. No buffer size. Cool. Okay, so this works. I guess I just write a test, honestly. Cool, so this works. Okay, we'll do this. Piece of shit language model. Did I say to fucking, like, change this? No. Thing, LR, EPS. That doesn't change anything. Yeah, it's super annoying. I'm trying to think what else I can do. Just keep heavy ball for a while, which is annoying. At least will give us one confident test. Why they seem stopped? Let me see. Ooh, because it looks like they did stop. Let's see why. I mean, they look good regardless, but why the hell did they stop? It says done. 3.7 or is 1.6 bill. Their max cost. There's no max cost on here. Oh, 1 hour max cost. Lovely. So they took an hour. We gotta fix that. I mean, let's just check if they're the same at for bill. 0.61, 4.2 bill. Yeah, same thing, right? 6.1, yeah. Right on target. The same curve. And then these two are the ones that are messed up. let's real quick let's really quick just write a or port this thing so we can actually use it. The fuck? I see. Why they write their code like this, man? Why they gotta be weird? Quick question. Windows which? Top 3. Which do ML switch from notebooks? Just Python CLI. Just grab NVIDIA. I mean, grab Ubuntu. It's the easiest, the best supported thing. Yeah. And yes, if you're doing any sort of serious engineering, you should not be working in notebooks. There are a very few select scientists, like very good scientists, who work out of notebooks. And all of them that I know were supported very heavily by a bunch of engineers to actually do the engineering. I gotta go in a few minutes, folks. So just before I forget, this is all open source. I do this type of stream and dev pretty much every day. Puffer.ai. If you want to support the project, you can star the repo right here. It helps a lot. All the devs on Discord. Join there if you want to get involved. And you can follow me on X for more content, including my educational stuff. What the heck did they do? What did they do? Contribute in Puffer? Yeah, the easiest thing is to grab Ubuntu and then just use the Docker because it has everything preset up for you. You can also do from source with UV. That'll also work. If you don't want to bother with Docker. Wait, grads is empty. And muon is just func, which is single tensor muon. It is not single tensor muon because this is dumb as hell. See. Dude, how's this thing supposed to work? Weird code. Init group. Oh, wait, it calls... Yeah, this is needed, actually. Calls this before muon. Inside the loop. Lovely. The init group. Like this. Cool. Well, that's the start of an implementation. I'm gonna have to do some more work on this in the evening, but I also have some client stuff to take care of. Oh shit, I totally forgot. Okay, never mind. Lucky me. I forgot to check an email, but I'm good. I told somebody I was free at 4 or 6, and luckily I didn't, luckily they said 6. No harm, no foul. What happens when I get absorbed, though, in this stuff? I'll set myself an alarm. Alright. Cool. Thank you, folks, for tuning in. I will be back tomorrow morning. I have some client stuff to work on tonight. And then I'm going to see if I can at some point carve out some additional time to make some progress here. At the very least, we have some very strong evidence that the new architecture is in fact good. And that actually the only problem that we're having is not being able to match the old optimizer. So, anyways, anything else? Oh, I think that is, yep, that's it. All right. Thank you. See ya.